In this video, I'll explain how to write the names and formulas for ionic compounds. First, we should review the charges that different elements on the periodic table make. In the first group, the charges will be 1+, because those elements will lose one electron. In the second group, the charges will be 2+. For transition metals, the charges can vary, and you can find them on a common ions reference sheet. For example, iron can have a 2+ charge or a 3+ charge. In the name, we use Roman numerals to indicate the charge. Iron 2 will be iron with a 2+ charge, and iron 3 will be iron with a 3+ charge. Elements in column 13 will have a 3+ charge. And in column 14, carbon and silicon don't usually form ions, while tin and lead could have a 2+ or a 4+ charge. For example, lead 2 is Pb2+, and lead 4 is Pb4+. Starting in group 15, the ions will have a 3 negative charge. In group 16, a 2 negative charge, and in group 17, a 1 negative charge, as these elements gain electrons. Elements in the last group are noble gases, and they don't form ions or form compounds. There's one last thing we should talk about before we start with examples. Nonmetal elements that form ions have different names than when they're neutral atoms. For example, chlorine can gain an electron to become chloride with a 1- charge. Oxygen can form oxide by gaining 2 electrons and gaining a 2- charge. These are called monoatomic anions because they're made of just one atom. In contrast, polyatomic anions will have more than one atom, and these can be found on a common ion reference sheet. Many polyatomic anions will contain oxygen, and they'll end in either ITE or ATE. ITE means there are fewer oxygens, and ATE means there are more oxygens. For example, nitrite has 2 oxygens, and nitrate has 3 oxygens. Now we'll go through several examples to explain how the names and formulas of ionic compounds are written. Sodium chloride is an ionic compound with the sodium cation and the chloride anion. Because chloride ends in IDE, we know that it's referring to the monoatomic anion straight from the periodic table with a 1- charge. So the two ions are Na1+ and Cl1-. Their charges equally balance and cancel each other out, making for a neutral compound, which all ionic compounds are. We can write this out as +1 + -1 = 0. Our next example is calcium fluoride, with the cation calcium and the anion fluoride. Calcium has a 2+ charge, and fluoride has a 1- charge. Unlike with sodium chloride, their charges don't cancel out. We need more of the negative charge to help them balance out. So we need 2 Fs, and that will give us 0 charge. So the formula of calcium fluoride is CaF2. It has an overall neutral charge. Our next example is iron 3 oxide. The cation is iron with a 3+ charge, which can be found on our common ion sheet, and oxide, which is a monoatomic anion on the periodic table. It has a 2- charge. You can see that these two ions together would have an overall positive charge, and we need to find a way to balance their charges out. If we have 2 of the positive 3 ions and 3 of the negative 2 ions, then they'll balance out to +6 and -6, and they'll be a neutral compound overall. So, the formula for iron 3 oxide is Fe2O3, 2 +3 ions and 3 -2 ions. In our next example, sodium carbonate, we'll have to use the common ion sheet because it includes a polyatomic ion. Carbonate is CO3 with a 2- charge, and the sodium has a 1+ charge. So we have Na1+ and CO3 2-. Again, their charges don't balance out. We'll need 2 of the positive sodium ions to balance out with the 2 negative charge of the carbonate. So, the formula for sodium carbonate is Na2CO3. While we use the charges to figure out the formulas of the compounds, we usually delete the charges when we're finished and only show the subscripts to indicate the number of each atom. Our next example is lead-2 acetate. Lead-2 is Pb2+, and acetate is a polyatomic anion consisting of 3 elements, carbon, hydrogen, and oxygen. Its formula is C2H3O2 1-. Like before, the charges don't balance out if we just have one cation and one anion. Since acetate has 3 different elements in the molecule, we're going to need to use parentheses to indicate that there are 2 of them. So the formula of the compound would be PbC2H3O2 2. The 2 outside the parentheses indicates there are 2 acetates. Remember to remove the charges when you're writing the final formula of the compound. Now let's go backwards and go from the formulas to the names. When we see the formula Au3PO4, we know we are talking about a compound that contains gold and a phosphorus oxygen compound. Since the formula is PO4, we know that we are talking about phosphate. What we don't know is which gold we're talking about. Is this gold 1 or is this gold 3? Since the phosphate has a 3- charge, we can figure out that the gold has a 1+ charge since we have 3 of them. 3 +1 golds will cancel out with 1 -3 phosphate. And that makes a neutral compound. Here's a visual to help you see how the charges cancel out. If I have 3 +1 charges, they can cancel out with the -3 charge. And overall, the compound is neutral. In this next example, we have lead and bromine. Lead can have either a 2+ or a 4+ charge, while bromine has a 1- charge. Since there are 2 bromines in the compound, and bromine has a -1 charge, we can figure out that the lead has to have a 2+ charge to balance out. Therefore, the name of the compound is lead-2 bromide. Remember, we changed the ending of the anion to IDE because it's a monoatomic anion. That indicates that it has the -1 charge rather than being neutral. Well, that's an overview of how to write the names and formulas of ionic compounds. The key to mastering this is practice.